Not all quadratic equations have real solutions. Sometimes we end up with imaginary answers, and that can occur when we're solving equations using our completing the square technique. So take, for example, x squared plus 4x plus 8 equals 0. So clearly that's not factorable. There's no two numbers that multiply to make 8, but add to make 4. So I'm going to have to solve using our completing the square approach. So to start off with, I'm going to subtract 8 from both sides. So I've got x squared plus 4x equals negative 8. I have to isolate those x's. So now I've got to come up with a number that's going to complete the square for us. So in this case, I'm going to take the number that's in front of the x, the b, divided by 2, and then square it. So 4 divided by 2 is 2, so 2 squared is 4. So I'm going to add 4 to both sides. So that's going to be my completing the square step. So on the right hand side, we're ending up with negative 8 plus 4 is negative 4. On the left hand side, I'm going to factor it into x, and then remember it's always the same thing twice, so I can write it as x, and then it's half of the b before we square it. So half of 4 is 2, so it's going to be x plus 2 squared. So at this point, we're ready to take the square root of both sides, and this is where we can see that we're going to end up with an imaginary answer. Because although on the left-hand side, I just get x plus 2, because the square and the square root cancel each other out. On the right-hand side, I'm taking the square root of a negative number. So I still need my plus or minus, and I'm going to separate out the square root of 4 from the negative, so the square root of negative 1. So I've got x plus 2 equals, now over here I can go ahead and take the square root of 4, that's 2, and then of course the square root of negative 1, we replace that with I. And so now I'm ready for my last step to get x by itself. I'm going to subtract 2 from both sides, so I get x equals, and I've got negative 2 plus or minus 2i. So we can solve using completing the square and get complex answers just because we end up taking the square root of a negative at that square root step in the process. For the second one, you'll recall that we can't complete the square as long as there is a number in front of the x squared other than 1. So I'm going to have to divide everything in the problem by 2. So that's going to leave me with x squared minus 10 divided by 2 is 5x, and 24 divided by 2 is 12, and then of course 0 divided by 2 is 0. So now I need to isolate the x's, so I'm going to subtract 12 from both sides. So I've got x squared minus 5x, I'll leave a little space, equals negative 12. I now need to complete the square, I have to come up with that number. So I'm going to take that negative 5, I'm going to put it over 2, and then I'm going to square it. So negative 5 times negative 5 is 25, 2 times 2 is 4, so I've got 25 fourths that I'm going to add to both sides. So we've got that. So I'm going to put this negative 12 over 1, and then I need a common denominator to be able to add those fractions on the right hand side. So I'm going to multiply by 4 on the top and bottom. So on this right hand side, I've got negative 12 times 4 is negative 48 over 4 plus 25 over 4. On the other side, I can go ahead and factor. Now we don't want to get distracted by that odd number there in the fraction in our factorization. It's always x, and then half of the number that's in front of the b before we square it. So it's always this number right here. So it's going to be minus 5 halves. So now I'm ready to add these numbers together on the right hand side. So negative 48 plus 25 in my numerator, the 4 just stays in the denominator. So I'm going to get negative 23 up top. There we go. And then on this other side I still have this x minus 5 halves squared. So I'm at the point where I can take the square root of both sides. And once again we can see we're taking the square root of a negative on that right hand side. So over here I'm just getting x minus 5 halves. On the other side, I'm going to take the square root of the top and bottom separately. So square root of 4 is 2. And then up top, 23, I can't factor tree that at all, but I need my plus or minus, and taking the square root of negative 23, I need to separate out the square root of 23 and the square root of negative 1. Let's make sure that looks like a 23 there. So square root of 23. So I'm going to scroll down a little bit, give ourselves a little more room. So I'm going to have x minus 5 halves equals. Now I'm going to change that root negative 1 to I. So I'm going to have plus or minus root 23 times I, making sure that that I doesn't look like it's underneath the square root symbol. And then I still have it over 2. So my last step, I'm going to add 5 halves to both sides. So I've isolated my x, and similar as we've seen before with these fraction problems, I've got the same denominator everywhere. So I'm going to just put a 2 in the bottom, and then up in the numerator, I'm just going to combine those two into one numerator. So I've got 5 plus or minus, and we can either write it as I times the square root of 23, or the square root of 23 times I, as long as we make sure that that I is not underneath the square root symbol.